Thank you for joining me today. I will start with this problem. I am given a beam. Looks like it's a wood beam. It's not a big deal in this course. A is a hinge. This support A is considered as a hinge. B is considered as a roller. We are looking to figure out the three internal forces: axial force, capital N, shear force, capital V, bending moment, capital M, at specific point C. If you remember what I said on Tuesday, we have to start first with reactions. Regardless what is the requirement, what is the point C, I don't care about all of this stuff, but my concern right now, I have two reactions at A because it's a hinge. So I have YA, I have XA. At B, I will have only one reaction because it's a roller, YB. If you remember in module number 5, I think, we covered if you have uniform distributed load. Do you remember that? If we have uniform distributed load with a value W, and the total length of this distributed load equal L, I will convert this distributed load to equivalent force, where at the centroid of this rectangle. So it will be at half span or half distance, L divide 2 and L divide 2. The value for this equivalent load will be the value of the distributed load W times the total length of the distributed load L. Does that make sense? Because we have this case right now. We are given a uniform distributed load 500 pounds per foot. This is the value of the distributed load over a total length equal 12 feet. So this distributed load will be converted to an equivalent force equal 500 times total length 12. It will be, I think, 6,000 pounds. Let me check, but I think it's 6,000. 500 times 12, 6,000. And this location, the location of this equivalent force will be at the mid-span, which is 6 feet on this side and 6 feet on the other side. Just a reminder, if we have a uniform distributed load, I need to convert it to equivalent. One equivalent force, it will be at the mid-span or at the mid-distance, and the value equal 500 times 12. Now I am ready to apply my equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0 to figure out their reactions. What reactions we have? Summation f of x equals 0. I think I have only positive XA. I think I don't have anything else in X direction, so XA will be 0. Summation f of y equals 0. We have positive YA, we have positive YB, we have negative 6,000. I think I don't have anything else in Y direction, equals 0. The third equilibrium equation, summation moment at any point. I do recommend to take moment at A, the point with the highest number of reactions. I can assume my clockwise rotation is my positive rotation. So I will take everything. XA time distance, YA time distance, 6,000 time distance, YB time distance, 900 time distance, 900 time distance equals 0. Keep in your mind, we have this 900 and we have this 900 and we have YA, XA, 6000, YB. Everything should be listed. I am sitting at A. So the distance between XA and A, 0. YA and A, 0. 6000 and A, this horizontal distance is 6 feet. YB and A, it will be 12 feet. Make sure your force and your distance are perpendicular. Anybody in this meeting can tell me what is the distance between this 900 at this location and the point A? Any help? 900 pound-foot is given at the end here. And we are taking a moment at A. So what is the distance between the two positions? Any help?
Which 900? Are we talking about the 900 at A or 900 at B?
No, 900, this one, which is located at the right end, and I am taking a moment at A. So what will be the distance?
There is no distance
What you mean by no distance?
because it's a moment.
Thank you. So we don't need distance. 900 does not need distance because it's already a moment. Keep in your mind, this XA is a force, need distance. This reaction is a force, need distance to create a moment. 6000 is a force, we need distance. YB is a force, need distance. But 900 is a moment, does not need distance. So it's wrong to include a distance. What you need only to say, that's it. For the second 900 also, we have another 900 here. The same also. We don't need distance, so it's wrong to include distance. It's wrong to say one or say anything. You have to say we don't need distance. 900 does not need distance. Does that make sense? So I will figure out the sign. I don't care about the sign of this term or this term. 6,000 times 6 will rotate clockwise, so it will be positive. YB times 12 will rotate upward, so it will be counterclockwise, will be negative. This given 900, based on the given direction, it's a clockwise, will be positive. Based on the given, this 900, it's given counterclockwise, it will be negative. So the only unknown in this equation is YB. Your YB will be 3,000 pound. If you go back here and put YB 3,000, I can say YA will equal also 3,000. So by the end of all of these calculations, I found YB equals 3,000 pound. YA will equal 3,000 pound. And the XA equal 0. This is the first step, which is reactions. Be careful, be smart. First, put your reactions. If you have uniform distributed load, what is the equivalent? Then go ahead and apply your equilibrium equations. You can find out your reactions very easy. That makes sense? Second step, if you remember, the second step to solve for the internal forces, axial force, shear force, bending moment at point C, I will do cut at point C. I will cut this beam to two parts, passing through point C. This cut will divide your beam to two parts, part on the right-hand side or another part on the left-hand side. Which side I'm gonna use, which part I'm gonna use, it's up to you. I can use the left part or the right part. It's up to you. So for me, I'm gonna use the right part. So after you did your section, this is step number 2. Section, I decided to use the right part. What do you have on the right part? We have this part. This is the right part until your cut, until your section. Let me draw it here. I have this part, looks like this. I did cut here at point C. I have point B at this location. At this point B, I have reaction YB equal 3000. We are given on this part at this end 900 pound-foot. And keep in your mind, on this part, I have this little part of the distributed load. This part only of the distributed load. So I have this part of the distributed load. What is the value of the distributed load? 500 pound per foot. 500 pound per foot. And keep in your mind, this distance equals 6 feet. And this distance equal 3 feet. This is the part on my right-hand side. One more time. Step number 2, at the given specific point C, I will do cut. This cut or this section will divide your structure or your beam to 2 parts, one on the right, one on the left. Which part I'm gonna use, it's up to you. I'm decided to use the right part. So what do you have on your right? I have this part of the beam, this part. So go ahead and draw this part with everything given on this part. Everything given on this part, I have 900, I have YB, I have part of the distributed load. And also at your cut, I should expect the 3 internal forces, capital N, which is axial force parallel to the beam, and I have shear force just a moment, I'm sorry. I have shear force, capital V, and also I have capital M, which is a moment. Once you set up your part and you put the internal forces at your section, I need to apply my equilibrium equation one more time. Summation f of x equals 0 for this part only. Summation f of y equals 0 for this part only. And the summation moment at any point equals 0 for this part only. Before starting to apply these equilibrium equations, I would like to say something. Right now, I have a little part of the distributed load, so I should expect another equivalent equal 500 times 6 feet only will give you 3,000 pounds. And this equivalent force will be at the mid distance. That means I have 3 feet from this side and another 3 feet from the other side. That makes sense? So don't be confused. We are working on this part only, and this part has a little of the distributed load, so we will have new equivalent and the new position. Previously, I was working with the whole distributed load. It's something else. Different story when you are talking about reactions. But right now, I'm talking about this part only, on the right part. That makes sense? Any questions so far? Okay. So let's start. Summation f of x equals 0. What forces do you have in x? I have only negative capital N. I think nothing else in x equals 0. Unfortunately, your axial force will be 0. That's fine. We don't have axial force. Summation f of y equals 0. I have positive v. I have negative 3000. I have positive 3000. Nothing else. This one will cancel this one. Your v will be 0. That's fine. Summation moment. I do recommend to take moment at the cut. See? Then you can assume what you want. I will assume clockwise rotation is my positive. Taking a moment at C, I have capital N time distance, capital V time distance. I have capital moment does not need distance. Your N is a force, your V is a force, your M is a moment. If you have a moment, we don't need distance. And we have 3000 time distance 3 feet. And we have another 3000, the reaction YB, time distance 6 feet. And we have another moment 900 does not need distance, equal 0. Keep in your mind, this capital N, the distance equals 0, V, the distance equals 0, M does not need distance, 3000 need the distance 3 feet. I'm talking about the 3000 for the equivalent. The second 3000 is a reaction YB, and the 900 by the end does not need distance. I don't care about the term, this term or this term. Your moment is given like clockwise, it will be positive. The first 3000 will be clockwise also. The second 3000 will be counterclockwise, will be negative. 900 is given like clockwise, will be positive. The only unknown in this equation is your capital M. Your value of M, I think, will be 3000 times 3 minus 3000 times 6 plus 9000, oh my goodness, equals 0. That's fine. Everything equals 0. No problem. So, looks like, I will give you a hint right now. Looks like at point C, which is given in this beam, here, the internal forces, axial force equals 0, shear force equals 0, bending moment equals 0. I will give you a hint. If you are a civil engineer or mechanical engineer or industrial engineer or any major of engineer, and I will ask you, hey guys, we have a beam. What is the best location to make a hole in this beam? Sometimes we have ducts for air conditions or any system for the drainage, for water supplies, for any purpose, for electricity, and we need to make a hole in the beam. Sometimes you can make a hole and the beam will fail. We can expect failure, damage. But I think point C will be the best point to make or to drill a hole. Do you know why? Because at point C, we don't have any internal forces. Nothing, no stress. This point is not stressed at all in this beam. Just, I would like to give you just a hint. What is the main benefit of engineering mechanics? Later, we will take more decisions, more calculations to figure out what is the best location to drill a hole for ducts, for pipeline, for electricity ducts, for any purpose. Point C will be the best location and the least risk for any failure. This is something outside the scope of this course, but just to give you a reminder, to solve this kind of problem, we need to start first with reaction. After you did, I will cut at point C. I will decide which part I'm gonna use. Once you draw your part with everything, put at your cut 3 internal forces, apply your equilibrium equations, you can find the internal forces. Anybody has any questions so far?
Doctor, I think the moment on that one is actually 8,100 pounds,
Oh, really?
pounds per foot.
Let me
Yeah,
check. So we have this M positive. This 3,000 will be positive times 3. This 3,000 times 6 will be negative. This 900. Let me check. So I have 3,000 times 3. Yeah, you are right. Looks like I thought this one is 9,000. Okay. Minus 3,000 times 6. Yeah, plus 900. You are good. Thank you. This value is not 0. This value is 8,100 negative. That's fine. We don't have normal, we don't have shear, but we have moment. That means maybe point C is not a best choice to make a hole. We can look for another point. Thank you for the correction. Okay, this is the first problem. Second problem, I am given also another beam with hinge at A, roller at B, and it's under the effect of uniform distributed load with two values, 200 pound per foot, 300 pound per foot. That's fine. I'm looking for axial force, shear force, bending moment at specific point C. Regardless what is the requirement, I'm gonna start with the reactions. First of all, what reactions did you have? At A, it's a hinge. I have two reactions, YA, XA. At B, we have one reaction. It's a roller, YB. So I will apply the three equilibrium equations. Summation F of X equals 0. Summation F of Y equals 0. Summation moment at any point equals 0. But before starting, I would like to give you a hint. We have this distributed load, so we should convert it to equivalent. How much? 200 times 4. It will be 800 pound. And this distance will be 2 feet. And this distance will be 2 feet. We have one more. We have one more. This distributed load will have equivalent at the mid-span, 300 times 8. The total length of this distributed load is 8 feet times 300. It will be 2,400 pound. 300 times 8. And this distance will be 4 feet, and this distance will be 4 feet. That makes sense? Now, I am ready to apply my equilibrium equations. Summation F of X equals 0. I think XA will be 0. Summation F of Y equals 0. I have positive YA. I have positive YB. I have negative 800 pound. I have negative 2,400 pound equals 0. So I can say YA plus YB equal 3,200. Summation moment. I'm gonna take moment at A. I'm gonna assume my clockwise rotation is my positive rotation. So I have XA time distance. I have YA time distance. I have 800 time distance. I have 2400 time distance. I have YB time distance equals 0. I have to list everything. Remember, we are sitting at A. So the distance between XA and A, 0. YA and A, 0. 800 and A, it's 2 feet. 2400 and A, it's 4 feet. YB and A, it's 8 feet. I don't care about the sign of this term or this term. 800 times 2 will rotate downward, that will be counterclockwise, will be negative. 2400 rotate down, but will rotate clockwise, it will be positive. YB, it will be rotate counterclockwise, will be negative. The only unknown in this equation is YB. I can figure it out. So negative 800 times 2 plus 2400 times 4 divided by 8, it will be 1000 pound. Let me check it one more time. So I have 2400 times 4 minus 800 times 2 divided by 8. Yes, 1000. So this reaction equal 1000 pound. If you put YB here 1000, the value of YA will be 2200 or 20,200. These are your reactions. YB, YA, and XA. XA equal 0. Once you set up your reactions, I will do the next step. My next step is I will do cut at point C. This cut will divide your beam to 2 parts. I will decide to use the smallest, the most easy part, which is the right one. Most easy means smaller part, means the part with less number of loads, the part which is not more complicated. That makes sense? Both of them will give you the same answer. By the way, if you decided to use CE, it will be the same if you use the CF. But I do prefer to use the most easy part. So I decided to use the right part. What do you have in your right? This is the next step. Step number 2. After you did your section, I have the right part, which is CE. You have to draw it. Here is your cut. Here is your point C. Here is your point E. What do you have on this part? I have point B with the reaction 1000. At this point, I have reaction here YB equal 1000 pound. What else? On this part from C to B, I have a little part of the distributed load, this part only. So I have a part here of the distributed load between C and B. What was the value of this distributed load? 3,300 pound per foot. Keep in your mind, this distance equal, this distance equal. How much? 4 feet and 4 feet. Nothing else. Nothing else on the right part from C to E. But keep in your mind, at your cut, I should put 3 internal forces, capital N, capital V and your moment. Once you set up your part and the given reaction and the distributed load, and at your cut we have 3 internal forces, I can apply the 3-Crobem equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. But before starting to do this, we have a little bit of the distributed load, so I will do a new equivalent based on this part only. So 300 times 4 will be 1200 pound. And this distance will be 2 feet. And this distance will be 2 feet. That makes sense? Then go ahead and start. Summation f of x, I have negative n equals 0. So your capital N will be 0. We don't have axial force. Summation f of y equals 0. We have positive v, negative 1200, positive 1000, nothing else, nothing else, equals 0. So the value of v will be positive 200 pound. I will take moment at the cut C. I'm gonna assume this clockwise rotation is my positive direction. So capital N time distance, capital V time distance. Your moment does not need distance. 1200 time distance, and YB, which is 1000 time distance, equals 0. I think the distance between capital N and C, 0. Capital V and C, 0. M does not need distance. The distance between 1200 here and C will be 2 feet. The distance between 1000 at B and C, it will be 4 feet. This term and this term will be 0. Your moment based on this direction and your assumption will be clockwise, positive. 1200 times 2 based on this assumption will be positive, clockwise. YB 1000 times 4 will be counterclockwise, will be negative. The only unknown in this equation is your capital M. I can find it out. It will be 1200 times 2 minus 1000 times 4. I got positive 1600 pound foot. So the 3 internal forces, axial force equals 0, shear force equal 200 pound, and the bending moment equals 1600 pound foot at point C in this beam. So far, I think so good. Any question? We have a new idea in this problem, which is very important. Let's see. We are looking for the same also. We are looking for the internal forces, axial force, capital N, shear force, capital V, bending moment, capital M, at point D. We can figure out the internal forces in this problem without reaction, but we need to calculate reactions to cover this new idea. We are given A is a hinge. That's fine. We have 2 reactions. And we are given a new member here called the CB. This member is called 2-force member. This member is special. This member has 2 ends, C and B. C is a pin. B is another pin connected to the beam. If you would like to start to figure out the reactions for this kind of problems, I will remove the member CB. I'm gonna remove member CB, which is 2 force member. Forget it. And then I will put a reaction at B on the same direction of this member. That makes sense? So this 2 force member will provide, this member will provide a reaction, one reaction to the beam in the same direction of the member. Since this member is inclined like this, your reaction will be inclined like this. This angle theta will be the same like this angle theta. Does that make sense? This is a special case, special member called 2 force member. If you have this case, I'm gonna remove it, delete it, forget it, and put one reaction in the same direction of this member. B sides at A, it's a hinge. So I will have YA and XA. It's a hinge, regular hinge. B sides, we are given this concentrated force 800 Newton and this force 600 Newton. And also we are given a moment here 900 Newton meter. Does that make sense? Go ahead and apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. We are ready to figure out the reactions. But keep in your mind, I cannot start right now until you break this reaction to 2 components. The horizontal one will be r cosine, the vertical one will be r sine. And also keep in your mind that this angle theta will be inside this right angle triangle. This horizontal distance is 2. This vertical distance is 1.5. So the hypotenuse, I think, will be 2.5. Let me check. 4 plus, yes, 2.5. So I can say sine theta will be 1.5 divided by 2.5. Cosine theta will be 2 divided by 2.5. That makes sense? Just to give you a hint. If you apply summation f of x equals 0, I have negative xa, I have positive r cosine theta, nothing else. Yes, I do have cosine theta equal 2 divided by 2.5, but I'm still having 2 unknowns, xa and r. I don't know any of them. So leave it. Summation f of y equals 0. We have in y positive ya. We have positive negative 600. We have positive r sine theta. We have negative 800 equals 0. Yes, I do have the value of sine theta equal 1.5 divided by 2.5. However, ya and r still unknowns. I cannot do anything more. Leave it. Summation moment at any point equals 0. I do recommend to take moment at A, which is the point with the highest number of reactions. I'm gonna assume my clockwise rotation is my positive. Then I need to multiply xa time distance, ya time distance, 600 time distance, r cosine theta time distance, r sine theta time distance, 800 time distance, and 900 does not need distance, equal 0. Be careful. Be careful. And pay attention for this. 900, this one is a moment. Does not need distance. So don't think about any distance for this moment. Let's say we are sitting at A. So the distance between XA and A, 0. YA and A, 0. 600 and A, I think between 600 and A, this distance equal 1 meter. R cosine theta here and A, 0. R sine theta and A, it will be 2 meter. Hey, wait. R cosine theta at point B. R sine theta also at point B. So why one of them has a distance 0 and one of them has a distance 2? First of all, the distance between B and A, yes, it's 2 meters. But keep in your mind, R cosine theta is a horizontal component. If your force is horizontal, your distance must be vertical. Do you have a vertical distance between B and A? No, your distance will be 0. R sine theta is a vertical component. That means your distance will be horizontal. Do you have a horizontal distance between the two locations? Yes, 2 meters. 800 Newton at the end, and the point A, the distance will be 4 meters. And the 900 does not need distance. It's a moment. I don't care about this term. This term, 600 times 1 will be clockwise positive. I don't care about this term. This component time 2 will be negative counterclockwise. This one will be positive clockwise. This one is positive clockwise. The only unknown in this equation is your reaction R. So what will be the reaction R? So I have 600 times 1 plus 800 times 4 plus 900 divided by 2 times sine theta is 1.5 divided by 2.5. Wow, I got very huge number. 3,916.67. Let me check this value one more time. So I have 600 times 1 plus 800 times 4 plus 900, yeah, divided by 2 divided by sine, this angle is 1.5 divided by 2.5. Yes, my number is correct. Once you get the value R, I can go back here and put R with this value, 3,916.67. I can find out the reaction YA. The reaction YA will be 950. So this reaction is 950. I can go back here and put R with this value, 3,916.67. I can find out the value of X8 will be positive. It will be 313. I'm sorry, 3,133.3. So I found the two reactions at A. I found the force in the inclined member, which is called two force member. Now, I need to figure out the internal forces, axial force, shear force, and the bending moment at point D. The next step, I will do cut. Then I will decide to use the right part, this part. Because we have another option to use the left part. The left part is more complicated. We have many things, and both of them will give you the same answer. So we need to select one of them. So if you decided to use the right part will be like this. So step number 2, your section. I have this little part. Here is your section. This point is called D. At this position, I have 800 as a force. I am given a moment as 900. What else? Nothing else. The length of this part is 1 meter. Should be given. We are ready. I have axial force, capital N. I have shear force, capital V. I have bending moment, capital M. One more time, go ahead and apply your Coulomb equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. You can find out your internal force. I think capital N will be 0. I think positive V minus 800 will be 0. So your V will be 800. If you take moment at D, if you assume clockwise rotation is your positive, so capital N time distance, capital V time distance, your capital M does not need distance, and we have 800 time distance, and we have 900 does not need distance, equals 0. 800 will be multiplied by 1, V and N will be multiplied by 0, based on your assumption. This term will be 0. Your capital M will be positive. Your force 800 will be positive. Your moment 900 will be positive. The only unknown is your moment will be negative. It will be 1700 Newton meter. So this is your axial force. This is your shear force. This is your bending moment. So the new point in this problem for your reactions, we have one hinge at A, and we are given a two force member, CB. This two force member is a special member. You can remove it and put one reaction R in the same direction of this member. The same direction exactly. And this is the reason why this angle is the same like this angle for the member. Then I can start and apply my Coulomb equation, summation f of x, summation f of y, and summation moment. So you can find out your reactions. I will go quickly for this problem. We have the same idea like the previous examples. In this one, we have a member called the CB as a two force member. In this member, we have a cable. This one is a cable. If you would like to figure out the reactions, that means this is your beam at this hinge A. I have two reactions, YA, XA. At this circle or pulley, I will have this cable and I will remove it and put a force F or R or whatever. So go ahead and cut this cable, which is supported by this hook to support your beam. Once you delete or cut this hook, or I'm sorry, this cable, we should expect a force in this cable like this. That makes sense? Besides, we have here 20 kilonewton. Now we are ready to figure out the reactions. Keep in your mind, this vertical distance will be 0.6 meter. It's not 0.5. 0.5 until the center of this pulley. But we still have radius 0.1 meter. So the total distance from the force and this center line will be 0.6 meter. This is the main idea in this problem. Then go ahead and apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. You can find out the reactions and the force R in the cable. Does that make sense? Once you get your reactions, I can do cut at point C. Then I will decide to use the right part and apply one more time the equilibrium equations to find out the three internal forces: axial force, shear force, and bending moment. That makes sense? Does that make sense? Go ahead and solve this problem. If you have any question, just let me know on Tuesday. Guys, do you have any question?
No, I don't think so.
Okay, so the main idea for this part of Module 7, I'm giving you a beam. I'm giving you a specific point. I'm looking for what are the internal forces at this specific point. The same steps. First of all, we need to figure out the reaction. Sometimes I will give you a problem with an idea like this one. The main idea here, we have a two force member, remove it, put one reaction in the same member. For this problem, we are given a cable. Go ahead and remove it and put one force in this cable. Capital F, capital R, whatever.